Welcome back, everybody. This is going to be part 3 of 6 in my lecture series on sketching the graph of functions using transformations. In this video, we're going to take a look at reflections, which is another type of transformation. If you haven't seen the first part in this video series, though, please go back and watch it now, as it's going to be important for this one. Let's get started. Reflection is exactly what you think it would be. Here, the graph of y equals negative f of x is the exact same as the graph of y equals f of x, but reflected over the x-axis. So when my output is negative, I flip over the x-axis. For example, to put this in the context of problems we have already seen, if I've got y equals x here, y equals negative x, I know through other means, looks like this guy. And it looks like I just flipped it around the x-axis. Similarly, when I have y equals f of negative x, that means my input has the minus sign on it. That looks the same just around the y-axis. But that one's a little bit trickier. Let's take a look at a few examples to help us straighten it out. Let's start simple and sketch the graph of r of x equals negative x cubed. And again, I need to give myself a little bit more room off to the side here. So, again, just like with the translations, the first step that I want to do is start from the parent function. In this case, the parent function is x cubed, which I can sketch the graph of since I know my parent functions and what they look like. All three of these guys are on the graph, and I'm going to sketch it with a dotted line since this isn't actually the function I'm trying to graph. This is just going to help me get my bearings. Then, notice for this one, I've got a minus sign on the output. This is not on the input, otherwise it would look like this guy. So, these two, for this case, happen to be equal because we have odd symmetry for this function, but not generally speaking. So, I want to flip over the the x axis. How do I do that? I want to bring everything over the x axis. What that entails mathematically is changing the sign on the output, right? That's literally what this guy is telling me to do. Start from x cubed, but change the sign on the output. So, I'm going to change 1 to 1, to 1, negative 1, and I'm going to change negative 1 to negative 1, 1. 0, 0 doesn't actually go anywhere. And what we get is this guy as the final graph. Let's try another one, though. Now here you'll notice we've got a negative sign on the input. So my parent function is the cubed root of x. And I know that actually has the same 3 points on it that x cubed does. Except that the shape of the graph looks a little bit different. This guy looks more like this. And now what I want to do is I want to flip over the y-axis since my input is being changed. How do I do that? Well, this is literally telling me change the sign on the input variable. So 1 becomes negative 1. And negative 1 becomes 1. -1. And now I can fill in the graph. So I'm going to let you guys try one on your own. Notice that there's a few things going on here. I've got a constant on the outside. That means I'm going to shift vertically. I've got a constant on the inside. So that means I'm going to shift horizontally. I've got a negative sign on the outside, which means I'm going to flip over the x-axis. And I've got a negative sign on the inside, which means I'm going to flip over the y-axis also. But what order do I do them in? That's a big question. In general, we work our way inside out. So my steps would be, first, I do still start from the parent function each time. In this case, my parent is x squared, since I've got a quadratic. Next, I want to reflect. My next innermost operation would be this minus sign here. So I want to reflect over the y-axis. Then my next innermost operation would be this 2. So I want to shift, again, for the horizontal ones, it's backwards, so I want to shift left 2. Then I've got this minus sign. So I want to reflect over the x-axis. And then last but not least, all the way on the outside, I've got this 4. So I want to shift up 4. Go ahead and pause the video here to see if you can sketch the graph. After all of those transformations, the dark blue line here would be the final graph. But let's break down how I got there. Again, starting from the parent function, the first thing I was supposed to do was reflect over the y-axis. But you'll notice, because I've already got symmetry over the y-axis, nothing actually changes. So I don't go anywhere. Then the next step, step 3, is where I move to this gray line here by shifting to the left 2. From there, I need to reflect over the over the x-axis, which is where this light blue line comes in. So from the gray line, I reflect over the x-axis and end up with the light blue line, and then I need to shift up 4 units to the final graph, which is going to be the dark blue line. In this video, we looked at how to graph reflections. And then we also took a look at an example where we've got both reflections and translations in the same function. In the next video, we're going to talk about a new kind of transformation. I'll catch y'all in the next one.